So, good morning dear students. So let's start our today's class with a packing efficiency for different structure. Okay, so before this let's discuss what is packing efficiency. Okay, now for this we take an example of the 2D arrangement in a crystal. Okay, so if you concentrate on this structure, then you will find that only some of the space are occupied by these particles. Okay, and there is a little free space out of the total space. Okay, so the packing efficiency means the percentage of the total space occupied by these particles excluding this free space. Okay, so that percentage is known as what? Packing efficiency. So now the packing efficiency for CCP or FCC structure. Okay, now for this we have to consider one FCC structure, and we know that in FCC structure there is an extra atom for each phase. Okay, now we have to consider any one phase from this structure. Okay, now let us consider this phase from the FCC structure. Okay, so this point is this point is this point is this, and this point is this, and the middle sphere is this sphere which is present at the center of this phase. Okay, now if you consider this point as the center of this sphere, then the distance from this point to this will be what? R, that means radius. And if this is the center of this sphere, then this distance will be R and this distance will be R. And if this is the center of this sphere, then this distance will be R. Yes, so from A to C we will get total how many R? Total 4 R. Okay, now we have to consider this BC, that means the H length of the BC, and AB as A, that means small a. Okay, and the phase diagonal AC as B. Okay, and from this structure we will get how many triangle? 2 triangle, but we have to consider just one triangle. Okay, so let us consider triangle A, B and C. Okay, now by applying the Pythagoras theorem we can write what? AC square equal to AB square plus BC square. But AC square equal to BC square plus AB square. Now just put the value of BC, AB and AC in this formula. Okay, so after putting the values you will get the value of B as root 2 A. Okay, so here we consider R as what? Radius, and we already discussed that in the phase diagonal we got total how many R? 4 R, and we consider the AC as B, so we can write B is equal to 4 R. Okay, now from this value we got what? H length A is equal to 2 root 2 R, and after that from this we got the value of radius as A by 2 root 2 R. So this is the relationship between the radius and the H length for FCC or CCP structure. Okay, now from these values we will now gonna calculate the packing efficiency. Okay, so the formula for packing efficiency is equal to volume occupied by 4 sphere in the unit cell divided by total volume in the unit cell into 100%. Okay, this is 100% because we calculate the packing efficiency in percentage. Yes or no? Yes. Okay, so here this is 4 because in the FCC structure there are total 4 atoms are there. Okay, so the volume of the 4 sphere is equal to 4 into 4 by 3 pi r cube. Now pi this one is the what? Volume, and into 4, that means the total number of atoms in the FCC structure, and we know that the volume of the cube is A cube, so this will be 2 root 2 R whole cube. So after calculation you will get a 74%. That means in HCP and CCP, also in FCC structure there are total 74% of the packing efficiency. That means from the total space of the FCC structure only 74% of the space is occupied by the particles. Okay.